Hey everyone, welcome back. Today, we're diving into a few fun Arduino activities that show how simple components can come together to make some pretty cool interactive projects. Let's get started. First up, Activity 2, the Spaceship Interface. You'll need an Arduino Uno, a breadboard, a push button, one green LED, two red LEDs, three 220 ohms resistors, a 10,000 ohms resistor, jumper wires, and a USB cable. First, connect the Arduino's 5 volts and GND pins to the breadboard's power rails to supply power. Then, place the LEDs on the breadboard. The green LED goes to pin 3 and the two red LEDs to pins 4 and 5 each with a 220 ohms resistor connected to ground. Next, wire the LEDs anodes to their respective pins on the Arduino. Add the push button across the breadboard gap, connecting one side to 5 volts and the other to pin 2, along with a 10,000 ohms pull-down resistor to ground. Finally, review all connections to ensure the LEDs and button are wired correctly before uploading the code. Once the code is uploaded, it's time to test your setup. The green LED should stay on when the button isn't pressed. When you press the button, the green LED turns off and the two red LEDs flash alternately like a warning signal. Next up, Activity 3, the Levometer. You'll need an Arduino Uno, a breadboard, a TMP36 temperature sensor, 3 LEDs, three 220 ohms resistors, jumper wires, and a USB cable. Start by connecting the Arduino's 5 volts pin to the breadboard's positive rail and the GND pin to the negative rail to provide power for the entire circuit. Place the TMP36 temperature sensor on the breadboard with its flat side facing you. Connect the left pin of the sensor to 5 volts, the middle pin to analog input AO, and the right pin to ground. This setup allows the Arduino to read the voltage from the sensor and translate it into temperature values in Celsius. Be sure to double-check the orientation of the TMP36, as reversing the pins can cause inaccurate readings or damage the sensor. Next, place the 3 LEDs on the breadboard. Connect a 220 ohms resistor to the short LED cathode of each LED, and then attach the other end of the resistors to the ground rail. Use jumper wires to connect the longer legs anodes of the LEDs to digital pins 2, 3, and 4 on the Arduino. This wiring allows each LED to be controlled individually, lighting up based on how high the temperature gets. When the temperature is low, only one LED will turn on. As it increases, 2 LEDs will light up, and when it's hot, all 3 will glow. Once everything is wired correctly, carefully review your setup to ensure that all connections are secure and placed in the correct rows on the breadboard. Then, upload the Levometer code to your Arduino using the Arduino IDE. After uploading, open the serial monitor to view the live temperature readings. When you touch the sensor, the warmth from your hand will cause the readings to rise, and the LEDs will light up progressively. For the final project, Activity 4, the Color Mixing Lamp. You'll need an Arduino Uno, a breadboard, 1 RGB LED, 3 photoresistors LDRs, 3 10,000 ohms resistors, 3 220 ohms resistors, red, green, and blue color filters, jumper wires, and a USB cable. Begin by connecting the Arduino's 5 volts pin to the breadboard's positive rail and the GND pin to the negative rail to power the circuit. Place the RGB LED on the breadboard, making sure each of its 4 legs sits on a separate row. The longest leg is the common cathode, which you'll connect to the ground rail through a 220 ohms resistor. The remaining 3 legs represent the red, green, and blue channels. Connect these to the Arduino's PWM pins 9, 10, and 11 using jumper wires, allowing the Arduino to control the brightness of each color individually. Next, add the 3 photoresistors LDRs to the breadboard. Connect one side of each LDR to the 5 volts rail, and the other side to analog pins AO, A1, and A2. Then, connect a 10,000 ohms resistor from each of those same pins to ground. This setup forms 3 voltage dividers that let the Arduino detect the amount of light reaching each sensor. After wiring everything, double-check your connections, then upload the color mixing lamp code to your Arduino once the program is running. Open the serial monitor to see live readings from each photoresistor. Try shining light or shading the filters to see how the RGB LED responds. As the light levels change, the LED blends red, green, and blue light in different intensities, creating a smooth color mix that reacts to your environment.